Do you hear me well, by the way?
Yeah. All right. Welcome everyone to the platform sprint review. The bi-weekly review we had with the platform teams, Dash platform teams. We had the representatives of the 4 teams, the Tenderdash, the GroveDB, the SDK, and the protocol part of the platform teams. And we are going to present you, give you some updates about the latest results we had with the platform development. And we would like to welcome your questions. And please raise your questions, knowing that we are going to have a Q&A part at the very end of this session. And please formulate your questions as with regards to that we will be out of context. So just formulate your questions like you put in the context, put in the exact slide or the exact, I don't know, sentence that you are referring to, because it is quite hard to answer these questions without that context. So thank you very much. And also, please leave comments if you have some feedback, any feedback regarding to our work, even if you are happy or satisfied or unsatisfied. And the more details you give us, the better. We can learn from it, and we can hopefully change or consider changing our next endeavors, next activities based on those. So thank you for joining us. Without further delay, I will pass it to, and we will start with the Tenderdash part of the team. And as always, I forgot to introduce myself. My name is Balázs. I'm the Scrum Master of the teams. And we are here today without Maciek, the product owner for the platform teams. He is sick today, unfortunately. So you will have to, yeah, we will present you. We will try to substitute you, replace Maciek for this hour today. All right. I will pass it on to Ivan.
Thank you, Balázs.
Sure.
Since the Tenderdash team members are mostly on vacation this spring, I have the honor to inform you about their progress. It's pretty decent progress. Could you please switch to the next slide? Yeah. So the continuous goal of the team still is backporting. This week we faced with the actually last week we faced with the problem on testnet, and the team released a pretty quick patch release, which we're already testing. The problem was related to the chain code, what we get for about like 1 day or something. You probably remember this. And it was because of some bug what we had in the logic of the block time proposing. It's the consensus mechanism to agree between the network what the time right now in the network. So this problem was fixed, and the side problem when if the network is stuck and Tenderdash isn't able to produce the blocks, it creates many tries. It calls the rounds in Tenderdash polka, consensus polka. So even if you restart it, it tries to reload all these messages, and it takes like hours. And guys fix that, so now it takes like minutes to replay all these P2P messages. So yeah, right now we're testing this release on DevNet and going to deploy it to the testnet soon. Also, the team proceeded their work on the V8, and we consider it as the more or less stable to test on DevNet. And right now we're on the phase of integration. The new version of Tenderdash with the existing services of platform such as Drive and DAPI. There are some breaking changes which was introduced in Tendermint 035. So both teams, Protocol and Tenderdash, right now working on this. Also, guys continue to backporting the recent changes from the Tendermint core upstream. You may see they proceeding to stabilizing this branch. So removing like some race conditions and stabilizing the integration of our changes with the upstream code. Yep, I think that's about it. Good job, guys. Lucas, Dima, hello.
Hello. All right, thank you very much. So we'll continue with GroveDB and proofs. I pass it on to Wisdom.
Hey guys, can you hear me well?
Yep.
Okay. So for this sprint, we kept on working on proofs. Last time we had done the proofs for path queries without subqueries. This sprint we worked on constructing proofs for path queries with subqueries and verifying the proofs also. So that was done. And then a really challenging task that we also completed this sprint is the substitution of reference nodes for the elements that they reference. So basically, to save space, it doesn't make sense to duplicate your data every single time it is used in the database. So sometimes you can have pointers to that data, and then when you request the proof, we need to send you the original data that it is pointing to. So we completed that also. And finally, the proofs feature is done. I didn't have so much time to create a comprehensive demo, but then I worked on something small just to at least show what we have implemented. So I would share my screen now. Can you see my screen?
Yep.
Cool. Okay, so we have to ask ourselves, what is the point of proofs? The point of proof is that you want to outsource something, but then you don't want to compromise on whatever it is that you are outsourcing, whether this is computation or storage, whatever you want. Let's say you don't have the capacity to, for example, store your data locally and make sure that it is available for as long as you want and anybody can reach it. So you want to now store this on, let's say, the Dash network or let's say MongoDB cluster. But then traditionally, you had to trust whoever you're storing this data with to do right by you, in the sense that if you ask them to store something, they are going to store it. If you ask for something back, they're supposed to give you exactly what you put in initially. So you traditionally have to trust this, and this is a centralization point, and it's a possible attack vector. So with proofs allows you to simulate the effect of storing your data locally, where you know everything works the way it's supposed to work, but then without having to have all those resource constraints. Let's say you need a super powerful machine, or you need a machine that anybody can access. So storing your data on the Dash network, we now allow you to ask for proofs in order to verify yourself without having access to the data that what you have stored on the network is exactly what we have given you. So you don't have to trust the network, you don't have to trust the masternode, you just have to trust cryptography, which is really, really cool. So what we have here is this screen is a version, let's say a version of a masternode. So this is like a masternode on the Dash network. Now, this masternode has some data. This is just a list of names of people, first name, last name. And then this is you right here. So here, I specifically created a completely new project in order to really like show this point. This one has no access to this data. So this data is stored somewhere else completely. And then this version of the project has no access to this data. So the only thing that this has access to is the root hash. So this is the root hash of the database. You can think of the root hash as like a fingerprint for the data that you have stored. So every time you add something to this place, it generates a new fingerprint. Now this fingerprint is protected by consensus. So we have Tenderdash, and Tenderdash is going to make sure that you can trust the this root hash. So now the only thing to be clear that you need in order to verify your proofs is this root hash. So the way this works is you take the names, we insert it into the database, and then I don't need to print the root hash anymore, but here we can now make a query. So what I did was that because of normally you would send a network request to the master node will generate the proof and reply back with the proof. But this time I'm going to be doing it through a file. So I have a file, proof.txt, that we are going to write the proof that we generate for whatever we do. And then this one reads that file. So they're not communicating, they're only reading proofs through a file. So that's the interface. And then we would verify the result of this. So I have some sample queries here just to make things easier for myself. I didn't have enough time to set this up. There are cooler stuff that I could have shown, but so what I've done now is let me copy this in a sec. Okay, so this is the first query. The query gets the list of all the persons that you have in the database. So let's run this. Okay, so it has written the proof to the file. And then if I run this one, we get back the results. So this is my name, and this is the list of the other people that are in this database. Now, to be clear, they are not communicating. This has no access to the data. It just, okay, let's just continue. I'm getting too excited. The next thing is the first name. So let's sort the query by first name. Let's generate another proof. This has been written to the file. And then you can see now that the first name is sorted. So we can generate proofs not just for all the data, but we can generate proofs also for sorted or more complex queries. So imagine running all SQL queries on or having a proof for each results that you get. So let's okay, there's no need to sort by last name since that has already been proven. Let me get all the first names greater than Diana also sorted. So let's run this. It has written the proof to a file, and then we get our result. Oh no, this is wrong. Give me a sec. Yeah. One sec. Okay. Let's try it again. Okay, so now we can see that the result set is actually now correct. Next thing is we can actually limit our results. So right now we are returning everything, but then we can limit it to just the first two. And then we can also limit this to the first two. If we run this, it generates the proof. And if we run this, you can see that we only see the first two persons. So another feature of this is that if you have different parameters, so let's say you were expecting the first three, that was your query. Your initial query was for the database to give you back the first three that fits this. And then the database instead ran for just the first two. You can also detect errors like this in the proof. So you can see proof is missing data for query. So invalid proof verification parameters because of it was expecting something else. So this is just a very brief, there's more that I could have done, but it's a brief display of the feature that we have been implementing all this while. So I'm going to give it to Igor.
Before you do, I just want to say that's amazing, Wisdom. This is
Thank you very much.
This is one of the piece of puzzles that we had to complete, guys, and I almost want to cry after seeing it.
Difficult.
Yeah, well done.
And I really love that enthusiasm that Wisdom puts into this.
It's
excitement.
The thing that's actually really also amazing is that this has never been done before in the history of mankind, for what I know, at least. So,
oh, it's really cool. All right, and I certainly haven't seen anybody so excited about proofs ever.
Proofs
in
are
my
the
life,
future.
so.
They are the future. Really.
All right, thank you very much. And let's continue with the SDK part. Did I?
Okay,
Yeah.
guys. Okay. Yeah, the spring goal for the sprint was finalization of persistent storage improvements and fixes. And originally, it was a simple regression after a huge refactoring, but we also decided to kind of lay a foundation for further change and fix some bugs because it didn't really make sense to restore storage to this state it's been before the refactoring. It had some bugs and was unusable in certain cases. So here is the list of what we accomplished. I'll go quickly one by one. First of all, of course, we simply fixed the missing persistent storage. It hasn't been saved by the wallet library. The next quite interesting bug appeared when we were trying to build UTXO state from multiple transactions, and some of them were chained within the same block. So we had a broken sorting for that. And eventually it resolved in TXLog errors coming from the Dash core. Next thing, this was about the third bullet point. And second, yeah, basically we had a bug of selection of immature Coinbase inputs. Fourth bullet point is optimization. Originally, we were storing basically everything in persistent storage, including the UTXO state and the whole set of BIP 44, BIP 32/44 addresses. And ultimately, this thing could be derived on the fly from transactions and from your mnemonic or private key. So we didn't need that. So we completely cleaned this up and implemented a couple of new functions that does that on the fly. Fifth thing, yeah, that's simple, error handling and additional logging, nothing fancy. We cleaned up some legacy code, cleaned up some obsolete mocks, and aligned some tests. And lastly, unfortunately, we didn't have time and capability to implement proper end-to-end tests for storage, and end-to-end tests are the only reliable thing, to be honest, to test such kind of integration. We had integration tests for that, but end-to-end is better solution, but we didn't have time for that. So we kind of embedded local forage and node forage libraries into a platform test suite, which is a little bit radical, I would say, but it attaches the success of platform test suite to the success of storage, and it makes us sure that on the basic level, storage functionality is operating as needed. And we extensively tested that in DashMate and testnet. And while we were testing it in testnet, we managed to catch many other bugs and fix them as well. So I'm handing this over to Mikhail, and he will say about the rest and demonstrate some of the things we've done.
Hello, my name is Mikhail. I'm from the SDK team. We embedded local forage and node forage into platform test suite. That means that it now creates client every time in our tests on the platform test suite. That means that we have more consistency, more stability over the builds. Also, we returned the dump storage function into the wallet. This function is not really used inside our client wallet in the DashPay, but rather needed for developers that use our SDK. Another big thing that we have done is the validation of storage integrity and versioning of our wallet chain store and wallet store schemas. That does mean that if wallets gets loaded with some inconsistent storage, then it will get wiped and resynced again. So we could have a fresh schema up to date. So let me show you how it basically works. Can you see my screen?
I do. All good.
Okay. Okay, I will switch to the master branch. There we have previous version of our persistent storage schema. I prepared a little test and a test account which already have some transactions in it. So I will now try to load the wallet. After the load, the persistent storage file should be created. Let's wait a few seconds to populate. Here we go. In our previous version, it looks like this. We have a lot of data that we don't use anymore. That was Igor talked about optimizing storage. All of this data.
This is the stuff we're calculating on the fly currently. The whole sheet, sheet of items you see.
Yeah. If we switch back to the V23 branch, wait a second. And try to run the same file. It will load the wallet, check the consistency of the storage. So the file should be resynced with the fresh schema. Okay. Here we see it is updated. Now we have the version field. That means that current our wallet persistent storage schema is number 1, version 1. It have now optimized storage schema that doesn't store a lot of paths and other things related to the previous version. And yeah, this is how it works now, basically. So that's
Thank you. Thank you very much. All right. And Ashur.
Yeah. Thank you, Mikhail. Let's proceed to the next slide. Yeah, there it is. So other than that, we implemented 2 small fixes requested by Dash Incubator. And our effort related to SPD block headers is ongoing. And yeah, that's about it pretty much. So the goal for the next sprint would be releasing all the stuff that we've made. So we want to get this out as soon as possible to be tested. And yeah, thank you.
All right, thank you.
Handing this over to Ivan, I think.
Yeah, exactly. Thank you, Igor. Thank you, Mikhail. And protocol part. And we are
cool.
at half time right now.
Oh, great. Thank you, Balázs. So for the protocol team, we have like 2 goals for the sprint. Is to continue implementation of the new fee system and complete identities according to DEEP11. Yeah, could you please switch to the next slide? Thanks. So we planned some tasks for the fees during the sprint, and the first one, actually, Sam, you worked on this. Do you want to talk about it?
Yeah, sure. So there were some parts that I hadn't finished last review that I finished, which was the runtime fee calculation for document query. I think I finished around 2 weeks ago. So it was at the very beginning of the sprint. That's about it.
Yeah, so basically rationale behind of this is that we can calculate how much resources, computational resources and storage resources we are spending to perform queries of the documents, which is kind of like pretty frequent operation during the validation of the state transition. So having this information allows us to calculate fees for state transition. Thank you, Sam. Also, we work on the binding for Node.js. Basically, we need we should be able to use the fee calculation formula and operations. What was done in RS Drive, in JS Drive, and this work is done. So now we have fee functionality in JS Drive as well. Runtime fee calculation, this task is started just recently. So basically we calculate fee in RS Drive at this moment, but we are not still calculating in JS Drive, and we implementing this part right now. It's in progress. And the last one, I would love to talk about it more in details. If you remember last sprint review, Paul Delucia presented some numbers, some research regarding the document insertion time, and the numbers was not really cool actually. So from what we saw, so what conclusions we made from these numbers, that majority of time are taken by validation logic, which we didn't plan to calculate for the fees. So our initial assumption was that I/O operations are the most resource intensive. So and others are just a dust, and we can ignore them. But those numbers show us that it seems like I/O is just like less than 10%, and the rest is something which you know what. And having this on the plate, it's kind of obvious that there are some attack vectors that we can perform to load the network and don't pay for this load, basically. So to make sure that we are going on the right, path, and what exact operations we need to take into account for fee calculation, we conducted more detailed research this sprint to gather the numbers from specific operations in more low level. And oh, I think we missed one slide. Yeah, thank you. So during the research, we faced with the two bottlenecks. What's happening during the state transition validation process, and the first one was the slow binding for the regular expression engine. This close read tool made by Google, and at least it says that it allow you to perform like regex in linear time. So it's one of the best protection from the re-DOS attack, when you can create the regular expression in a way that it's super slow. And Paul presented this last time. So we used the last binding, we changed it to another one, native node one, and it's super fast. So this was just optimization problem. And another one, we encountered that we compile JSON schema from data contract every time we validate documents. I think it wasn't something new for us. It's just because that we never worked yet on the optimization, because usually it's the last stage, and we're planning this work for 24, version 24. But still, it's like pretty interesting finding. So introducing caching in persistent caching solves this problem as well. So you may see in the next slide the new numbers. The left numbers, the numbers in milliseconds. And the left is the before optimizations, and 32. Oh, sorry, and the second one is after, and the difference in percentage. So we tested as normal strings, documents with normal strings, plain strings, documents with regex, with indices, and also with unique, the combination of unique and normal second indices. And from what you see right now, the more we utilize the basically the storage. So if you're using indices, you store more data and read more data, and especially with the unique indices, because we need to validate state transition again state during the validation process, you see that the percentage of the difference is lower. So it made us think that probably we are close to our initial assumption that only the I/O operations are most time-consuming ones. Could you please switch to the next slide? Yeah, and we group the logic, the operation, the logic during the state transition validation and execution, when we store state transition in state. You may see that before optimization, the difference was like not so big, but after optimization, we see that actually the majority of the time taken by I/O. Yeah, so it's like more than 90%. Thanks, and could you please switch to the next slide? So basically, the conclusion is that there is a room for optimization still, and we need to work on this when the feature complete. And our initial assumption that for MVP it's the tracking only I/O operations is a pretty appropriate solution, and we go in the right direction. We did not apply the optimization what I mentioned right now because we made it like in a hacky way just for the testing, and this work will be done as part of V24. Yep, that's it. And for this investigation, we made a small tool like Benchmark Suite to collect the numbers. It's integrated into the platform, so you guys can use it for your needs, and we are going to use it later as well in the optimization state during the stress test stage. So this tool allows you to define two types of the benchmarks. First one is the documents. So you can, it's like configuration, and you can create any number of benchmarks that you want, and you define the this one will be more representative. You define the data contract, and you generate documents what you want to send, and you may apply some statistic function to get the average value of the calls. And the second one, so basically it creates state transition and send this state transition to the network and gather the numbers, the metrics from the drive log and show you back. And the second one, it's more like for low-level testing, so you can define tests with specific logic, like running specific functions, and using the Node.js performance module, you can measure different values and get them back. So it basically looks like this. Yeah, so it shows on the overall, but you can have a detailed report as well. Yeah, that's it. Thank you.
Thank you.
Let's make this kitty cat as a shareable module so that we all can use it in our demos.
Yeah, I could hear the noise as well.
So you can, it's just reported for Mocha. You really can use it.
All right. So Ivan or Javid?
Yeah, Javid, are you there?
Ivan, can you take it over?
Yeah, sure. No problem. So we also worked on the identities. So you probably noticed that Deep11 defines many features, but they're not actually implemented in the protocol level. And we decided to catch up before the MVP. So we continue to implement features, and that's actually the last from the list. The first one is the update mechanism for identity. Previously, if you create identity, it was immutable and there was no way to update it or change. And we implemented the functionality to add new keys to identity or disable existing ones. And yeah, and updated also JS SDK, so you can use this feature. The second one is more like the security improvement. So previously you could add public key to your identity even if you are not owning this key, so you can take it from everywhere. And there are some attack vectors on this. So we introduced we call it ownership proof. So basically when you submit your identity, you need to sign and provide signatures for all keys, what inside. And the signatures must be created with the private keys corresponding to this public keys what you're sending in the identity. So you kind of make sure that you definitely have this private key if you publishing the public key for that. The next one is more like improvement required by master identities. And the idea is that for master identity, we can create a withdrawal key based on the script payout and script creator payout. So on layer 2, to get the rewards, you can use the same mechanism, the same credentials, same wallet, what you're using to receive rewards from layer 1 from the core. So that was the last from the feature set of the master identities. And this task represents the next one, integration of the platform with Tenderdash version 0.08. It's the same story what we already discussed when we talked about the Tenderdash teamwork. And so basically, protocol team integrating the new Tenderdash with the Drive and 23 version. This work in progress still. We didn't expect that there are many breaking changes in the new version. Yeah, thank you, Balázs.
Thank you, Ivan. Thank you, Ivan. And for the demo as well. All right, and let's move on with the DashPay demo on testnet. We have a related question to that as well, and I just pass it on to Hash Engineering.
All right, thank you. Let me share my screen. So should be up now. Let's say,
Yes.
thank you. So I'm Hash Engineering on Discord, but Eric Britton in real life. I am one of the Android developers, and I'll be doing a live demo of DashPay today. Let's say that we have two users, Bob and Alice. So on our left side, we'll have Alice's device, and on the right side, we'll have Bob. So let's say that they have met and they've just upgraded DashPay from Dash Wallet, and now they want to create their usernames. Both of these wallets are set up with one test-to-dash right now. So we'll start with Alice first. So we're going to create a username and we'll call it Alice Test. And then we'll press register. And there is a fee for this. Right now it's set at 0.01 dash, but that may change later depending on the fee structure that platform decides. So we will confirm and pay. We can get a different view of the status of the username creation by clicking here. It'll go to the home screen and it's showing like there are 3 steps that are happening. So there are a total of 3 state transitions that are being like sent off to platform. And one of the reasons why we haven't released DashPay yet is because we were concerned about how long that process is taking. So we're doing time studies right now to see how long. So that one didn't seem that long, but we have seen it take up to a minute. Let's now create Bob's username. That looks like a bug. I think something went wrong there. So that's another reason why some of my DashPay hasn't been released yet, at least for Android. We are finding some bugs that we need to fix. They're not related to platform specifically. It's just the Android code and stuff that we've got crashes. In fact, our QA found one yesterday that we're gonna have to fix. All right, so while Bob is registering, let's say that Alice wants to set a profile picture and stuff. So we can go to the profile part of our DashPay app and say that Alice wants to put her username or her display name, which will be also seen by Bob later as Alice. And then let's pick an image from the gallery, which this is an emulated device. So it's just going to be a generic emulated image of a picture of a wooden cat. So there is some option here to like zoom in and stuff, but I'm not going to do that. We can choose what service we want to store our image on because it needs to be on the internet somewhere so other people can get access to it when they do username searches and stuff. So we'll pick Imager and we will agree to the terms. Now we can save our profile. All right, so Bob will do the same thing. Except in this case, Bob will use a Gravatar account. Which happens to be Captain Kirk in black and white. So we'll save that. So Alice has saved the profile. So we'll go back to the home screen. If we click on this Hello Alice test card, it'll give us like the first thing we would want to do with DashPay, which is search for a friend, which in our case is going to be Bob. So as we see on the right side, Bob's profile has been updated. That means that the data on platform should also be updated. So if we search for Bob, we will find Bob's username, which is bob-test. And also we see his profile image. So if we click on it, then we want to send a contact request to Bob, which will also do another state transition to create a document that will link Alice and Bob. And that document will also contain information that will allow Bob to pay Alice directly without sharing addresses in the normal way that we often do. All right, we'll go back to the home screen. We see that on Bob's home screen, there's a second notification up here, so we should click on that and see what it is. The first one is just saying to invite your friends and family to join the Dash network, and that's a feature that's called the invite feature, which I'm not going to show today, but you guys can try it out when this gets released. So we see that Alice has sent a contact request to us, so we can press accept. So let's, on Alice's screen, let's go back to the home page. So we're still waiting for that to go through. So I switched to the contact screen, and we don't see the hourglass here anymore, which means the contact request went through. We also see on Alice's screen, if we were to click on notifications, that it says that Bob has accepted your contact request. So that's good. So let's say that Bob owes Alice for maybe a couple gallons of gas. So let's pay 0.2 dash to Alice. So all we did was we clicked on Alice's username thing, and then we said pay. On this enter amount screen, we'll just like in the regular Dash wallet, we can put in our amount, but it does tell us who we're paying to. So we press send, and it has our confirmation details, and we will actually send it. Then we see on Alice's screen that we have received a payment from Bob, 0.2. If we click on Bob's icon, we'll get the username history with Bob, and we will find that at the bottom, we sent a contact request and Bob accepted it. Later, Bob sent us 0.2 dash. And let's just say that maybe he gave us too much, or we need to pay Bob for a slice of pizza that we got the next day. So the payment has gone through. We see the notification over here. If we close that, we will see on our activity with Alice that first we sent 0.2 dash, but now we have received 0.05 dash from Alice. We can go back to the home screen and see that we have two transactions with Alice. One is sending, one is receiving. So that's all I have for today's demo. That's like the main functions of creating a username, searching for contacts, and adding contacts, accepting contact requests, doing profiles with pictures, and also sending payments.
Thank you very much.
I'm going to stop sharing. Thank you.
Yeah, thank you very much for sharing these. Let me share. Yeah. All right, and
I must admit that the guys, like mobile guys, in a pretty bad position because we desperately breaking the compatibility in the protocol, and they always need to catch up like every release, which is pretty difficult. So good job, Eric.
That was
Thank you,
amazing.
Ivan.
That was just really amazing. Okay, I'll continue on what's next. So as Ivan said earlier, we have this sprint we were going to work on the fee system implementation for validation, and we did some parts of that, but there was kind of a step back to figure out how exactly we should implement the validation part, and that's what Ivan showed today. So in the next sprint, we're going to continue on the fee system implementation, and hopefully complete that. There's also a part about finishing the identity work that we had according to DIP 11. There was a lot of work done this sprint on that. I think that there's one state transition we still need. Is that correct, Ivan?
No, actually, we implemented all of them.
Oh, okay. So that's an error, guys. We finished it already. Perfect. I mean, I guess there's the revoke one, right? But I'm not sure if we're going to do that before MVP.
Yeah, we're still discussing this.
Yes. So just for people in the audience, there's one, if in case you think a key got compromised, you can revoke your identity. But it's a pretty advanced feature, and we can delay that until after our mainnet release, I believe. So then on SDK, we're going to integrate SPV block headers into the wallet. I believe this is to speed things up. And then we're going to release several features and fixes that we currently have working, but it's on a side branch. Okay, next, GroveDB. So GroveDB, as people saw today, it works, but there are some big improvements that are needed in order to make the system more reliable and also to prevent certain attacks. One of those is GroveDB batching. Right now, before batching, there's a specific attack that could happen. And with batching, it should not be able to happen. So that's why we're going to be doing batching. It allows for atomic writes per state transition instead of right now, if a state transition were to fail, you would have to replay the whole block, and that can cause some problems. We're also going to work on a few more parts of proofs, most likely adding the ability to count. I forgot to put that in. Basically, right now, and it's not a very complex thing, but for example, if you want to get information back from a platform that doesn't actually give you back the information, but gives you more back proof on the count of the information. A good idea of this is like in voting, right? So if people were to vote for something, you don't care about who voted for what, but you care about the result of the vote. So you can use a count mechanism and it will give you back a proof, but the proof does not actually contain the data. It just contains proof that the data exists. The cool feature, and it will save a lot of time for verification. So that should be very cool. In Tenderdash, backports are being continued. Backport of version 35.2 of Tendermint. We're also starting the process of backporting the ABCI++, which is version 36. and that will allow for same block execution. Same block execution is something that we need for mainnet release, that Tendermint got in version 36. That's not yet released to Tendermint. So, it is something that we can get kind of for free from upstream. So we're backporting that. And we're also going to integrate the latest version of Tenderdash that's already out with platform. So let's open up to questions.
Let's open up to questions. Thank you very much. And big applause to everyone. Thank you. So the first question I see here is maybe Eric answered this, that when will the DashPay testnet update be released, and what are the issues why it has taken quite some time to release? I think it was answered partially.
Actually,
do you want to add?
Brian answered this already in chat.
All right, wonderful.
So I can just read his answer. Basically, that the reason why it's taken so long, as Ivan pointed out, is that we're constantly making updates. So as the mobile team makes it work, it breaks again. And this has kind of been happening quite a lot recently. So it's not at all the mobile team's fault. There's just a lot of things going on. Brian said, I'll know better in a few days, but it's likely that it will get pushed to next week, bearing no issues during our testing of the V18 upgrade of Dash Core. So,
all right. Thank you. Can you help me out with the roadmap question? That is it answered? I mean, have anybody linked the roadmap link? I mean, the question I see is there an up-to-date Dash roadmap available to view somewhere? And I believe it should be updated on our on our website. Let me go check to make sure. Yes, sir, the answer should be updated. And if it's not, we'll fix it in a matter of days. Yes, actually, so it has platform and core on here. It does not have mobile. That's the reason, I'm guessing, why they were asking that question. So yeah, we'll add in the mobile. I'll make sure that's done. Yeah, thank you. And another question, maybe to Igor. So no storage adapter error anymore.
Yeah, that's for me. Thank you for feedback. So it's good to know that this message is causing some concerns, because this is actually not an error, but a warning. And I would even say that this is an informational message for users. We'll consider change the text a little bit to for it to be less alarming. For now, no, this message won't be gone, because developers will still have to provide storage adapter from the outside, and by default, we don't have any built-in storage adapter. This is a topic of consideration.
All right, thank you very much. Do you see, as I'm sharing your screen, I don't see the actual feed. But do you see any more questions that is not answered yet? All right, then thank you everybody for the questions and the feedbacks you gave me. And I hope you enjoyed the review and the enthusiasm and the excitement, what we try to give you as a message, and see you in 2 weeks. Bye-bye.